Here we are asked to differentiate the pressure function. Here it's part of the ideal gas law. You see the P, V, and RT are all involved, but it is describing this equation is describing the pressure of gas in a cylinder at a constant temperature T and a volume V. So this volume V in a piston, as shown, is a variable because as the piston depresses, the volume of the gas will change. So the volume is the variable. The pressure is the dependent variable. As the volume changes, the pressure changes, but the temperature T is a constant, and so are all these other values, A, B, N, and R. So to take the derivative, we really just have to identify the thing that's a variable. Let me show you that perhaps in color. So N, R, T are constants, and so are N and B. A N squared divided by N. The variables here are the volume terms. So we want to differentiate this function pretending like all the stuff in black is a constant. It's just a number. So the derivative with respect to the variable volume of this equation is the derivative if pressure with respect to volume, the change in pressure with respect to the change in volume is, and then we'll look at this first term where we need to apply the quotient rule, the variables in the denominator. So we have low, d high, and the derivative of the top was a whole bunch of constants. Derivative of constants are 0, minus high, which is nRT, d low. So we have the derivative of the bottom, where we only have one variable. That variable is v. The derivative of v is 1, but the derivative of the constants nb is 0. So low d high minus high d low all over low squared. So that stuff didn't change. We didn't have to differentiate that. And then minus, just because I'm out of room to the right, the derivative of the second term. Again, you could think of it as a quotient rule, low d high minus high d low, or perhaps since you only have one monomial in the denominator, you could think of this as a constant, a n squared, times the variable v to the negative 2 power. Those thoughts really simplify this derivative. If we just raise the thing in the denominator to a negative exponent, now I don't have to apply the quotient rule. I simply have to do the power rule. That's negative 2. If I bring down the negative 2, the constants are along for the ride. A n squared still there, and then v to the negative 2 minus 1 power, or the negative 3rd power. And pretty nice. So let's clean up all this business. Anything times 0 in the numerator is 0, so then I just have negative nRT in the top divided by v minus nb squared minus negative 2, so plus 2 an squared v to the negative 3. And then just to rewrite it in the way that it was given before, we could put that v back in the denominator if you like. Negative nRT divided by v minus nb squared plus 2an squared divided by v cubed. Now this equation describes the change in pressure as we see a change in volume.